Okay, we are going to simplify these radicals. So I'm going to start with the first one, which is the square root of 98. Now, 98 on its own is not a perfect square, so I would recommend you factor. So I use just a factor tree. 98 could be divided by 2 because it's even. 2, you can use a calculator as well, but 2 goes into 9 4 times, bring down my 1, 49. Now, the great news is this 49 is a perfect square, and you can continue factoring it with 7 times 7 if you want, but you don't have to do that. So the way the product rule works is this now gives us, let me go back to my thing here. This now gives us the square root of 2 times 49 because they're equal to 98. So these inner values, these radicands, are equal to each other. Or actually, I'm gonna rewrite it a bit so that it's in an order that helps me better. 49 times 2. And I'm gonna use the product rule here now to split square root of 49 times square root of 2. Product rule says if they are sharing one radical, like 49 and 2 were, and they're multiplying, I can give them each their own radical, still multiplying. And that index, that invisible 2 square root that sits there, stays the same. So the square root of 49 is 7. I don't have a square root of 2. That's rational, meaning it is better for us to just leave it as a square root than throw it into a calculator. That's it. That's all you have to do. Second question, 150x to the fifth. Still square rooted. You'll notice I'm focusing mostly on square roots because that's more of what you're going to see in this class. So that's where our emphasis is. So I'm going to break this kind of into two pieces. I have this 150, again, not a perfect square root, but it does factor 10 and 15 because it ends in a 0, right? 5 and 2, 5 and 3. So number wise, this turns into 5 squared times 2 times 3. And just like we did above, if you'd rather write that as 25 versus 5 squared or 7 squared instead of 49, that all means the same thing. Do what you're comfortable with. But I also need to factor my x's here. So again, remembering there's an invisible 2, a square root that we're taking, right? So I want to split that x to the fifth up into values that will get uh, uh, be divisible by 2. So I'm gonna take out x squared. There's room for another x squared, and I'm left with an x. So if you remember your exponent laws, I will add my exponents. So I will add 2 plus 2 plus 1, and they will add up to 5. So 2 plus 2 plus 1, they add up. So those are my x's. So I'm going to include those here, x squared, and x. And those are all being square rooted. So it's lengthy because we've spread it out, but it's lengthy with a purpose, right? So I'm going to group together the pieces that are perfect squares. So I have a square root. That's a weird looking square root. Let me write I have my 5 squared first. I'm going to bring my x squared, my other x squared, and then put everyone that's not a perfect square last. So I have 2, 3, and x. And those are all going to sit under a square root. Okay, so again, product rule. 5 squared, square rooted. X squared, square rooted, another x squared, square rooted, and I'm going to keep 2 times 3 times x all under one square root, and you can simplify it sooner than I do if you want. So this gives me a 5, this gives me an x multiplying, this gives me an x, and this gives me 6x. This is still under a square root. These three are no longer under a square root, and I'm left with 5x squared square root 6x. Okay. All right, let's go on to another one. Okay. Okay, so number 3, I have 15 root 5 plus 7 root 45. So this is still the same product rule. We're still going to apply it. But what's kind of also happening here is I can only add what are called like radicals. I always sound like a Valley girl when I say those words together, like radicals. So that means that I can only add square roots of 5 to other things with square roots of 5 attached. So if there's a 2 here and a 6 here, the 2 and the 6 get added, and that square root 5 just tags along the same way that you would do things if that was an x, right? If this was a 2x and a 6x, you would add the 2 and the 6 to get an 8x, and that x would stay exactly the same. Same thing that you're doing here. So here, I can't do much with these radicals because the 5 and the 45 are not the same. But I want to point out this 45 can get simplified. So this can factor to a 9 and a 5. And I'm keeping my eye on that 5 because that's what I have over here. And this doesn't factor. I just get a 5 and a 1 that doesn't do anything. So lucky for us, this 9 is a perfect square. So maybe off to the side, I'm actually going to erase this part. Off to the side, I'm going to simplify this 7 root 45 just to clean it up. So 7, like a side scratch work, something like that. 7 root, come on, root 45 is 7 square root 9 times 5. 7 square root 9 times square root 5. That's my product rule that we're working on here. 7, now this square root 9 gives me a 3 root 5, and I multiply the 7 and 3 together to give me 21 square root 5. Now that is going to replace this. So we're going to have 15 square roots of 5 plus 21 square roots of 5. Now that these are both root 5s, I know I erased it over here, but now that these are both root 5s, I can add the 15 and the 21 together to get, what is that, 36 square root 5. There you go. So a little bit of extra review built in there, but that's okay. All right, last but not least, let's do number 4. Not sure what happened there. Number 4, 14 root 6 minus 6 root 24. Now this is going to be similar to what we did in the previous question, right? My question is, what can be simplified? What can be cleaned up? What are our options? Well, 6 is not prime, meaning I can factor this, but it's a 2 and a 3, and there's no perfect squares there. So it's probably in our best interest to just leave it as a 6, but let's see. 24 factors to 3 and 8. 8 gives us 2 and 4, and I am going to note 4 is a perfect square. So again, either you break this down further into 2 times 2, 2 squared. I'm just going to leave it as a 4. So it does not look like I can do much to this first one. I'm not going to touch that, but I am going to try to rewrite the second one. So I have this 6 square root 24, and that's going to be 6 times 4, 3, 2. So 6, 4, I wrote too much there. It's too long. This is my product rule step. Times root 3. Oh my gosh, what is happening? 3 times 2 So I have 6, the square root of 4 is 2, and that's going to be square root 6. So ultimately 12 square root 6. So just like the previous question, this is going to replace this. And notice now we're going to have root 6 for both. I actually could combine these now. So, okay, copy and paste 14 root 6 now minus 12 root 6 because they have the same number under the radical. Again, that's called a radicand. I can now focus on adding or subtracting the 14 and the 12, the numbers that sit out front. So this gives me 2 root 6. Okay,